You have to still take one off from there, detach this hood, and place it onto your calculator. So essentially, I don't know if you love your calculator a lot more than you could possibly love one of these yellow ones, but it all does the same stuff. So I really don't know why you would want to bring one from home, but apparently you can. But you have to have this hood on it, which if you want to buy a separate one, you can even have your whole own setup. But in any case, this hood lets your calculator connect to my computer. So what we're going to have you do to start with is this. Make sure that your calculator is out. Go to the home screen on it. And then go through and press 5 twice. 5, 5. It should come up with like a setup and login. Is that correct? Now, sometimes don't do this now unless this is you. Sometimes when you get in there, there's a button here that says log in. Sometimes that will be grayed out and not available as an option. If that in fact is the case, turn yours over, and on the back of it you see that there's a little button that says reset. Now, you gently, this is the part where some of us have some rage issues, safe for therapy. You take just the tip, you don't stab the back of the calculator, you just gently push it in. And it resets the calculator, like a hard reboot, like unplugging the computer, and it will find the network later on. Also, please refrain from drawing on these in any way. I don't go into your house and start drawing all over your stuff. Your username is going to be the first letter of your first name and then your last name. So if you're Bob Smith, your username is B. Smith. And your password is 1, 2, 3, 4. Yeah, so if you do, I literally saw in the first class, they actually wrote it on the side. It's 1, 2, 3, 4. And I don't remember everyone is 1, 2, 3, 4. So like when you say, oh, Dave, I forgot the password. Remember what it was? They go, oh, yes, 1, 2, 3, 4. So you'll notice that now, here's part of our problem that we're going to have in this class, and this is why I didn't do it last time. There was something that was wrong with the system, and it was only in your section. There are not 14 students logged. There are 14 people that got uploaded, but not 14 people in this room. If you look on so raise your hand if you're not on that list. Oh, literally, wow. We literally segregated the room somewhere. Does yours work?
He's turning wrong.
Yeah. Okay, so literally it's just these two rows? Oh, this is wonderful. That's what it must be. It's that first group. So, don't worry about it. We'll get yours fixed. Now that I know that it's just your 2 rows, I can easily hand you a trial, but I have to manually add all of you. So, you guys will be good. However, I will show you all this. This is why you go through and log in. Now, in the future, this is going to be everyone's. So, this allows me to see what's on every one of your computer screens now. So, if you're, let's say, not paying attention to us, or something, you're the one that I'm going to go through and think, I've got 15 people who are doing what they're supposed to, and one not. I'm still going to pick that one every time. As of now, your names are not on it. However, if after, maybe you say, oh, this person's not doing what we're supposed to, let's pick them, and then we're all staring, waiting for the one person. And if that person doesn't sort of self-correct and identify, we do publicly shame. By going through, we can also sort of track what you did. Here's one thing that you all need to get accustomed to doing that maybe, I don't know if they tell you this or not when you're coming up. There's 2 places that you can do computations. One is in Scratchpad and one is in a document. Don't use Scratchpad. It has no purpose. They should pretty much take it off. It's essentially an area for, imagine if you were to give your grandparents who've never had an iPhone, you know how they wouldn't know what to do? That's what Scratchpad is for, okay? So, you seem to be moderately technology savvy. We need to be able to store values and have full access to the full catalog of features that the calculator offers. That will not happen if you are in Scratchpad. And to make sure that you're never going to work in Scratchpad, I sporadically, especially in the beginning of the year, do this. So go into Scratchpad right now and start doing some computations. Just type in whatever you want.
So we got log in.
You guys, you 2 rows don't log in today, okay? In the future, by tomorrow, we should be able to have you, especially now that I know that it's just your 2 rows. So you're going in, you're doing your exam. You're like, oh, look at all of this. I'm computing. This is going wonderfully. I'm probably going to get 100 because I'm amazing at everything I do. And all of a sudden, so then I come through and do this. And what just happened to all your stress tests? They're gone. So, yes, it happens during a test. I can assure you, if you think that's bad now, I do the same thing to the kids, and this happened last semester. A girl that was in class almost had a heart attack at U of R. She was in the middle of her final. I said 100 times, stop using scratch pad. At some point during the exam, I'm going to clear it out. And I went through, and I asked somebody for a time at the beginning of the exam. It was 9:15. And so the exam started at like 8:30, probably halfway through the exam. You go and you put your scratch pad on everybody, volunteers, whatever. How many times do we need to tell you the same thing? You don't need to get told 100 times, don't play in the middle of the road. That's kind of thing you should just know. So, don't work in scratch pad. It's not going to help you at all. And everything that you can do in scratch pad, you can do in the other screens. So always work with documents instead. Now that that's done, we'll get you 2 guys set up for next class. Another thing too that sporadically happens, for those of you interested in, and yes, they're not rushed, because that's what one of the people saying, oh, I'm totally rushed in that assessment. You will in the beginning. You'll get over it, trust me. It's fine. Like, it's the same thing with running. Like, if I were to go run right now, just with I was already 4 or 5 minutes long. If I ran every day, I would get even faster at doing it. Okay? The same thing happens with you. You guys, in the beginning, in general, are terrible at any form of graded work because no one grades you on anything and you bring updates in your phone. You're going to have a bunch of other assessments. I put assessment 0 in as a mark, but not counted into your grade. Everything after this, though, will, but I just wanted to have something there so you know, oh, I got those right, or maybe I didn't get those right. And sporadically, one of the reasons that I asked you all to sign up for Remind is that this can get sent out to you. Now, I can't do it yet because there's other sections that haven't got it. Maybe I can, and I don't want to be sharing it with them. But sporadically, you'll get maybe a day later, or maybe even the afternoon of. This is the work level that I would expect from you. And watch how fast these should be happening. You look at the first question, you go, what is the GCF of that? All right, what can I divide out from all of them? I can take a 9 out from both, an x out, and a y out. So it's 9xy. Did I even need the remaining binomial? No. Then the next part, which one of those is equivalent to that? Well, I look at this, I can factor that by GCF, so there's a 2 can come out, an x, and a y, so I take that out. That's what I'm left with, answer choice C. Next 2, if this took us longer than 3 seconds, we're going to have an issue. Which one of those is a trinomial? Yeah, tri means 3, bi means 2. So, those ones are there. Which one shows out, or which one is the complete factorization, or sorry, well, that would be the complete factorization of it. To take out the GCF, which one is it going to be? Answer choice C. It's kind of easy. That one may take a little bit longer. It's kind of interesting because that's the one where you all tend to go to the calculator to go through and do it. We're not necessarily, by the way, saying that the other answers are wrong. Are they wrong? No. Why is, hands up please, you can tell me why C would be the correct answer, even though none of those 3 are wrong. How can something be right but not the correct answer? A and B just have a common factor identified, not the greatest. Okay? And it's very possible, by the way, that D can happen. I know that you all think that everything is correct. So these were the ones, too, where, again, I don't know why. This should have been, frankly, calculator free, and there's going to be times when you do work in your calculator, you take your calculator away. How do you go through and solve a proportion? Cross multiply, and that is equal, or sorry, set the sides equal. The product of the means is equal to the product of the extremes. And by the way, there were some of you that there was no algebra, like some math answer is there. Unless it says otherwise, please assume everything is algebraic, which means I need to see this amount of work here, like a justifying amount. And the last one that was bonus, so when you see it in the computer, it will be in out of 6 points with the possibility of you earning at most 7. You get a question like this. This would actually be a really good one not to have the calculator on because all the decimals you can even handle pretty well. You've got tough stuff like adding 0.8 to 0.2 together and solving that out. Those hopefully should have been pretty easy, and by and large, at least from the first section, the marks are very, very good. We have questions on anything from the assessment. Okay, hopefully we did very, very well. Maybe a 4 or 5 out of 6 and up. We left off last time we had class. We did a bunch, so we did all of these, right? Yeah. Let's take a look then. Let's go back to example 2. And let's look up at the top. Hands up, please, if you can tell me. Take a look at example 2B. And hands up, please, if you can tell me. You can use your calculator if you need it. I don't care. I want you to get things right, especially in the beginning as you get used to working with numbers. Hands up, please, if you can tell me what the GCF only, the GCF in 2B would be. Go ahead, please.
8p.
Now, after you take out an 8p cubed, hands up please if you can tell me the quantity that we would be left with after we take out a GCF of 8p cubed. So you're reverse distributing or undistributing that out. Tell me what we would have left. We'll wait for 5. I got 2 right away. Thank you. 3. 4. Now, do we have questions on that? I was actually really impressed with how far you took these, especially this question here. This is what I give the kids when I'm teaching at U of R college algebra and in the first day of calculus. That's the level of factoring that they are at, and that's the level of factoring that you could be at. There's nothing defective about any of you. You all, the one thing, and this is a big difference, you all are very adverse or afraid of risk, but you all are very, very bright people. And in order to get better, you actually have to get used to taking some risks and failing. It's okay to get stuck. We're going to give you long, complicated problems, but every one of you can digest and process what we went through and did. Take a look at example 4. Looking at what's there, there's actually 2 different ways that we can proceed in example 4. Hands up, please, if you can tell me what one of the 2 possible GCFs in example 4 could be. We got 1 so far, 2, 3. There's more than one correct answer to this. What would you like to say? No, sorry, for 4. Sorry. What could we pick as a GCF, for example, 4? Go ahead. You could pick an A out, and if you chose A, what would you then be left with? You're absolutely right. That's one option for a GCF. Some of you may see it differently because of even a problem that you see inherent to what you're now left with. Who can see a different GCF that they might want to identify? Go ahead. And what are you left with if you factor out a negative x?
Negative a squared minus 3a plus 5.
What was your first term again?
Negative a squared.
No.
A squared.
Yeah, it's going to be positive this time because you've got to factor that negative out from all 3 terms. Not just the a, but the negative as well. Now, which one am I probably going to prefer you to do? Well, as a mathematician, as you go forward, which one is the preferred vehicle? It's this one right here, because look at what remains. When our leading term is caught, that sets up visually, you are more accustomed to seeing that being factored. That's why we leave it in the form that we do. Is the one on the left wrong? No. This one's probably the one that we're going to aim for you to be at, though. All right. Now, we didn't get any of this page done. Is that right? Okay. So let's take a look. We're actually going to, and how about you had a factoring checklist or check down list that we did the other day? If you could keep that out on the side, because we're going to process what's there, especially for those of you that struggle and or struggle with when do I factor in different ways. You're going to want to keep that out and do it as literally a check down list. Is it one? No. Is it two? No. Is it three? And so on. Work your way down in that order. So let's start at the beginning. We're going to do out example 5. Is there a GCF for this entire expression in example 5? Yes or no? No, there's nothing that they all share in common. Second thing on your list, is that difference of perfect squares? Yes or no? Yeah, DOPS. Is this a difference of perfect squares? No, difference of perfect squares is two binomials being subtracted where both left and right half are perfect squares. That's not there. C, I think, is a fast factoring. Is that the one with the leading coefficient of 1?
Yeah.
Yeah. Is that this case? Is it? No. We don't even have a squared term. And we have 4 terms. Fast factoring is only going to have 3. Next one up is guess and check. Does this look like the guess and check example? No. Next one up is grouping. Does this look like the grouping example? I'd say it's got a lot of stuff similar to it. How many terms are there in that grouping example? How many terms? 4. How many do we have here? It tends to be that at your stage, I'm going to show you much different, and I'm going to show you every possible example. This works out to be grouping because there's not a squared term there. It's difficult to break this down. How grouping works, read what it says there. What does it ask us to do to identify or how to factor by grouping? Say take the GCF of the first 2 and then the GCF of the second 2 and then the GCF of the whole. Is that right? Something like that? So let's look at this. I've got 4 terms. Right off the bat, I look at the left 2 and the right 2. Looking at what's there, is there a GCF for the first 2 terms? Just the first 2. Hands up, please, if you can identify a GCF for those first 2. And what's left after you take out an A? You don't need that stuff. Take out an A, you've got an X minus Y is correct. Now let's look at the second 2 terms. Hands up, please, if you can identify a GCF for the second 2. Go ahead. What kind of B? Positive or negative? I'm going to say positive. And what's left when you factor out a positive B? Now, there's a reason that I harp on it, especially with the signs. If she had said, I'm taking out a negative B, she would not be wrong. But if at this point she factored out a negative B instead, you'd have negative B and then negative X plus Y. Why would we not want to factor out a negative B as opposed to the positive B that we did take out? Why would we want to take out a positive B instead of the negative one?
Oh, because that gets you the X minus Y for this one.
Yeah, then we find a new GCF of X minus Y. So we got a GCF here and here from our factorization. We've done a GCF twice. You can do it again. Look at the expression as a whole. What do the left and the right sides share? And X minus Y, yeah. And what's left when I divide that out? Go through right now on your own, please, and do out number 6 and 7. Take a look at where we stand right now in example 6. Looking at what's there for example 6, is there a GCF of the whole expression, yes or no? No. Is this a difference of perfect squares? No. Is this a fast factoring? No, because the lead coefficient is 1, there's 4 terms. Is this a guess and check factoring? Well, no, because this has 4 terms. Is this a factor by grouping? Let's try. Is there a GCF for the first 2 terms? Hands up, please, if you can identify it, if there is one. Careful, for 6. What's your GCF for the first 2? 3. And what's left after you take it out? There you go. Did I go over how to say that before, or no? When we talk about primitive quantity, you didn't need to say it there. But when we're saying it in the future, if you want those parentheses, there's there. Remember, numerators and denominators, when we're talking about fractions, there's square roots, radicands. We'll get to all of it. But make sure we're saying, and we're going to, well, you'll be sounding so smart. Is there a GCF for the second 2 terms? Hands up, please, if you can correctly identify. And there's going to be some opportunity for multiple answers here. What would you like to say?
Negative.
Who chose positive A? You're going to encounter an error. You wouldn't be wrong if you took out a positive A as well. Why would we choose the negative A? Yeah, our quantity that's left over wouldn't match. If you took out just a positive A, you'd have negative x plus y. It needs to be x minus y. So you were right. Take out that negative A, and I'm still now left with an x minus y. And this is the thing I love. You've got to get over, I'm going to get every question right every single time I try it. You're going to have mistakes. This is the perfect example. If you went through and did it as a positive A here, so if I factored out a positive A, I'd now be left with negative x plus y. You're not wrong, but why is that not the best choice? Looking at what's there, do my binomials match? Not if I choose the wrong of the GCF options. Looking at this from here, do I currently have a GCF of the big expression? Yeah, and what is that GCF? It's going to be x minus y, and it leaves you with 3 minus a. Questions on that? All right, and this is more of the same. Take a look at example 7. Hands up for the GCF of the first 2 terms in 7. And what's left when you take that 6x out? Hands up, please, when you can tell me the GCF from the second 2. And this is okay if you don't see it in the beginning. Go ahead. Close. You even kind of said it. Said that there's not 1.
1?
It's 1, yeah. So there isn't anything besides 1 that you can take out of that, but you need that 1 there. Go ahead.
Is it okay that I just, like, read it in order?
Now, hang on just a second. You're gonna answer your own question in about 40 seconds. Okay? Now, when we get to here, how would I give out my final answer? Well, there's a GCF of a plus 2b, and then 6x plus 1. Do we have questions on that one on the left? And by the way, you did it with reordering, is that right? Did you get that same answer?
Yeah.
There you go. If I took the product of those 2, I should get back that polynomial expression. Is there a question? Now, yeah, with these, does the order matter? No. I always like to put that GCF common factor in front, because visually I'm saying I'm dividing that out, and the second factor is what's left. Okay? Now, the question came up, can I reorder these? Let's find out. And apply the math that you already know, because technically, you already have the answer to that question that you answered. Looking at what's here, we're going to go down our checklist. Is there a GCF? Yes or no? No. Is there a difference of squares here? No. Is it a fast factoring? No. Is it a guess and check factoring? Well, we haven't done it yet, so it's probably not. Leaves us with grouping. This kind of sets up for grouping, except now I look at these terms and I'm going, oh, I look at the first 2 terms and the second 2 terms, and I'm ready to pack up and give up. Why? What is it? There's no GCF for the first two terms or the second two. What can I factor out from these two? 1. What can I factor out from those two? 1. Is that helping me? No. So instead of quitting, we say, well, wait a second. As I'm looking at this, I see terms there that kind of link up to each other a little bit. Yeah?
P squared, Q squared, and negative Q squared, and then negative.
You could do it more than one way. Does it matter which order the terms are listed in? And the answer is no, as long as you preserve the signs. Now, when I redid mine, and again, you don't have to exactly do what I did. I redid it this way. I did it as set my p squared, q squared minus the 2q squared. Then the other one I did the 5p squared and the negative 10. So that's how I reordered it. Why was it advantageous for us to reorder it in this fashion? Hands up, please, if you can tell me why this alternate equivalent expression is way more beneficial to us than the way that the original was stated. You got no people? Can you tell me? Why was this a good step to take? Or did I screw up? Which theoretically happens. Yeah, what's your GCF for the first two? Of my first two. Yours two, you may be different. You're going to get the right answer at the end. What's that? Q squared. And then what's left? Okay. Hands up, please, when you can tell me the GCF from the second two terms.
5.
What kind of 5?
Positive.
And what's left, please?
P squared minus 2.
There you go. Now, when I'm done, I can do a GCF again. What's our third GCF going to be? P squared minus 2. And it leaves me with q squared minus 5. By the way, I'm not done yet. I still need to check. Is there a GCF in either factor? No. Is there a difference of perfect squares left over? No. I will warn you, the reads, when you take it, they are going to probably give you something, let's say, actually, we'll do this. So let's say you get to this step and you've got x squared and then like 5, 9, minus 5. Let's finish this one out. Is there a GCF there between the left and the right half of this binomial? What is that GCF going to be? So I'm going to take out my x minus 5, and now I'm left with x squared minus 9. And boy, you better be really angry if I walk away right now. Hands up, please, if you can tell me why you would be angry if we stopped right now. This was on your paper. If I gave this to you, you should be outraged and offended. What? What does x squared minus 9 factor to? Hands up, please, if you can tell me. Take a look at your checklist if you need to see it. And it's okay to be wrong, but the part that is confusing is when I don't have some scrolling marquee on my forehead. I know I look very good, but I somehow mesmerize all of you when you stare at me like you're in focus. I'm not done. I've got an x squared minus 9 that you can do more with. Take a look at your factoring sheet. You can tell me what x squared minus 9 is going to break down into. We got 1. Even the directions on how to do it are there. See what's on, and if you're wrong, there's no trapdoor underneath your desk. It's going to drop you into some fiery pit. Not yet. What do you want to say? It's the square root of the left and the square root of the right with a plus and a minus between them. X squared minus 9 goes to x plus 3, x minus 3, x squared minus 16, blah, blah, blah. The read will give you something like this, and it will say factor completely. If you stop here, you're wrong. Right? Just so you know, that's a question that comes up in June, and we're going to be able to get it right on day 2. Now, let's keep going forward. This first one is done for us. We need values that are going to, well, the top of page 3. Our factoring checklist tells us first thing we need to look for is GCF, greatest common. And when I take a look at this first example, 1a, no common factor. Is it a difference of perfect squares? No. Is it a fast factoring? Yes, our lead coefficient is 1. It's a trinomial. So I need values that are going to multiply to the end value and add to the middle value. So what two numbers multiply to negative 35 and add to positive 2? Those numbers are 5 and 7. When I ask you the factors of this binomial, if you say 5 and 7, you are wrong. What are the binomial factors of this going to be? They're going to be x minus 7 and x minus 5. Binomials have two terms, not numbers. Take a look now, hands up if you can tell me what A is going to factor, or sorry, this A, what that trinomial is going to factor down into. Take a look at your check down list. Remember, you need numbers that multiply to the end value and add to the middle coefficient. Hands up, please, when you can tell me what two binomials A will factor down into, if it does factor. We got 1, 2, 3, 4. We'll wait for 7 of you. 1, 2, 3, 4, 5, 6. We're getting there. What do you want to say, please? Here we go. Do those numbers multiply to give me negative 30? Yes. Do they add to give me negative 1? Good job. Questions on that? How about please for B? Hands up please if you can tell me what B will factor down to. Hands up please and tell me what B will factor. I got 1, 2, 3, 4, 5, 6. Getting there. We're getting there. How about for example 2? Take a look at example 2 and hands up please and tell me what that's going to factor to. Now 1 person, 2. And did we talk about that you all do the rectangle thing before? Yeah. When we do this out, you're never going to see the rectangle, so we do first, outer, inner, last, and I'll show you how you can go about getting it. Go ahead. What did you want to factor 2 down to? So here's how we check to see if it in fact works. It's not, we're not taking somebody's word for it blindly every time. We're actually doing the math to verify that it's right. First terms, when I multiply together, that's the first in FOIL. F-O-I-L is the first. First terms multiply to give me m squared, so that's good. The outside terms multiply to give me a negative 1. And what do the inside terms multiply to give you? Positive 7. So what is 7 and negative 1 when you put them together? 6. Is that what we're looking to get? Yeah, who can tell me why this isn't the answer then? Hands up please, and tell me why this is not going to be your answer. We need this to be a positive 7 here, and this is negative. So do I make this a positive now and walk away? Because what's your inside value going to be when you do outside, inside? 8. Who's got a different idea as to what this is going to factor down into? What'd you say? Thank you. We went over this the other day. And by the way, that rewards those of you who read the question. It says right on it that it's prime. Literally, I had students at the U of R that were taking calculus that are engineering majors. And you put a question up that says factoring a prime polynomial. What does it mean? It didn't even say factoring, excuse me, it said recognizing a prime polynomial. What does it mean if something's prime? It doesn't factor down more than 1 in itself. That's the title of the question, is this doesn't factor down, and you still missed that. Take a look. This one is another example of when you don't see what's there, you get a little bit frustrated, and from my perspective, it's frustrated as well. Take a look, for example 3. When we're doing that out, it kind of looks like we should be able to do it and kind of doesn't. This, out of all of the choices that you have, this matches just a factoring by guess, or by grouping, or sorry, a fast factoring the most. Try to make yourself 2 sets of parentheses. Keeping in mind that when you do this operation here should, when we multiply everything out, give me back what the original is, right? So, in that yellow position, what we're putting there needs to multiply to what's in the front. So there's only really one option for what we can put in that yellow position. Hands up please if you can tell me what your only options really are if you're trying to have two binomials here and you want these to give me that. What options do we have to fill that first category? Does that make sense? Yeah, you can only put an X there. Now, the part at the end is kind of awkward because these pieces in green, what do they need to multiply to give you? Hands up please if you can tell me that. Follow the pattern that we did before. What do those green spots need to multiply to give me? I got 1, 2, 3, 4. What do you want to say those green spots are going to give me? Go ahead. Yeah, you- Close. We're not going to give you negative 16. Oh,
Negative 16a squared.
there you go. Negative 16a squared. It's got to give you that amount there. So, what could we put in those green spots? You can give me a candidate. Not what's going there. What are just candidates for going there? Doesn't matter if they go there or not. Go ahead.
8a and negative 2a.
Sure. What's another one we could have besides positive 8a, negative 2a? Or is that the only one that could possibly exist? Go ahead.
Positive 4a and negative 4a.
Positive 4a and negative 4a. What else? Yeah, some sign change on all of those, but those are the choices you've got. Now, we need to pick the one that when these are in front here, the foiling of that will give me positive 6ax. So, who's got a guess as to what they want to try to put there, and we'll try it out and see if it works, and if it doesn't, we'll erase. Go ahead. So positive 8a and negative 2a. So as I'm doing this, first terms give me x squared. The outside terms give me negative 2ax. Your inside terms multiplied together give you positive 8ax. What's negative 2 and then plus 8 going to give me? Positive 6. Is that what we were looking to get? Does that work? Now, here's the piece that I find the most frustrating because people quit on, and it breaks your heart every time. Actually, sorry, not the next one. It's the one after. Go through and do the next one, please, right now on your own. And factor it completely. Hands up, please, if you can tell me what you're going to do to start off example 4. You've got 1. That's it. Just your first step in example 4. I'd hope this would be the easiest part you could do. 2 of us? 3? What do you want to say?
Take out the 16y.
Take out a GCF of 16y, and what are you left with, please?
Y squared minus 2y minus 3.
Outstanding. Why would you be outraged and offended if we walked away right now? Go ahead. Yeah, that trinomial, you're not done. That's a fast factoring. Hands up, please, when you can tell me your final answer after you've completely factored what's there. We got 1, 2, 3. Let's open for more. Keep going. Your factorization is not done yet. There's more that you can do on what remains. Got 4. And what do you need to make sure you've got there in front of it? Yeah. Make sure that that piece is there, but we're good. Questions on that? This is the one now where we're going to have quitters. And it's very irritating. This is probably one of the hardest, and I always do it in the beginning because we'll make If the first one's hard, everything else after this will seem easy. I look at that right now. Is there a GCF? Yes or no? No. Is this a difference of perfect squares? No. Is this a fast factoring? No. Is this a factor by grouping? No. This is awkward because the leading coefficient is 12r squared. You're going to be so irritated. You would love this if it was 11r squared. You would love this if it was 13r squared. You don't want it to be 12. Why do you not want that lead coefficient to be 12 or 16? Why would you love a profoundly awkward number like 991 in the front as opposed to 12? Hands up, please, if you can tell me what makes this question such a challenge. Go ahead.
And it's not a prime number, but everything else.
When you say it, what's it?
That's what-
Okay, 12 is not a prime number. So we're going to make a candidate list of values that we can fill in the yellow spot. You can tell me one possibility for a pair that could go in that yellow position. Just one possibility that could go there. And? No. 6r and 2r is right. Who can give me another pair that could go in that spot? We got 3, 4 of us. Come on, go ahead. We could have a 3r and a 4r. Hands up, please, if you can tell me another one that could go in that spot.
12R and 6R.
Now, when we're doing this, you're actually lucky, and there's no more. Why are we glad to see 2 at the end? Why is 2 so much? Why is it a nice one to find again? You love seeing 2, you love seeing 5, you love seeing 3, you love seeing 8. Sorry, you don't want to see 8. You want to see 7. What? Prime. It's only got one arrangement you could have. There's a 2 and a 1, that's it. 4, it could be 2 and 2. So we've got a 2 here and a 1 here. And the sign in the middle is negative. So one of them is going to have to be positive and one's negative. This is why this way of factoring is called guess and check, because you actually just take a guess and then you check to see if that's right. That's it. Now, looking at what's there, what's one possibility to go in the front? Well, I'm going to give you one in the beginning. I'm going to tell you why you would never try this. To start off with, I'm going to try, let's say, the 6r and 2r. So I've got a 6r and a 2r. And at the blue, I need values that multiply to give me negative 2. So I say, let's say, negative 2 here and positive 1. Now, I'm going to attempt this. First terms, when I multiply them together, I get 12r squared. What do my outside terms give me?
6R.
Positive 6r. And what do the inside terms give me? Negative 4r. So what 6 and negative 4 are going to give you? 6 minus 4 is 2. What are we trying to get? Negative 5. So does this work? I'm going to tell you right now, it doesn't work, nor would I ever expect you to attempt this grouping of numbers. Why would I not want you to try this? Does anybody know why I wouldn't ever try? This can't be an answer. I know it before I even did the FOIL. Take a look at that first factor. Is there a GCF here?
Yes.
Is there a GCF here? Is there a GCF here?
Yes.
There is? Really? No, wait, no, there's one 5. If there's no GCF here, you shouldn't have a pair here. So like you wouldn't have 4 and 2 here either. Or 2 and 4, however the arrangement is, okay? Now, you're just going to try them. If they don't work out, that's why God invented erasers. Go in from here. What would we try in that first spot? And if I'm remembering correctly, I think it's 3 and 4. 3R, does anybody have it? Let's try 3 and 4. We need to get out a positive 5, so I think that this is negative 5, so I think it's minus 2 and plus 1. That's going to be the one that works. How can I check? First terms give me 12r squared. The outside gives me positive 3. The inside gives me negative 8. Okay? Now, for your homework tonight, here's what we'll ask you to go through and do. Oh, wait. Oh, do you have questions? Hang on. Head over, please, to page 5. And at the top of page 5, I'm going to ask you to do this. Try to get done, please, 1 through 16. They should be pretty quick. I don't envision you can do it right in that packet. It's fine. Okay? 1 through 16. Thank you very much. We will see you tomorrow. Will you see you tomorrow? No, sorry. We'll see you after that. We've got a lot of time to get this done. Okay. All right. See you later, guys. Have a good day.
Matt, are you coming to our match today?
If you have, I'll stop out after school. Sorry.
Alright. Sienna, where are you headed?
Do you have one on Thursday?
I have no clue.
Okay.
We beat Victor though.
I saw. I was very proud of you. You did great.
They changed the